Welcome, welcome, welcome. Okay, good evening. So today we are back with one more problem. I hope the video doesn't interfere with the question. Okay, so this is an application of conservation of momentum, but I see that most of the students make a mistake in this. Let me show you where do they get confused. Just a moment. My wire is not working properly. Okay. So now, what's it? So a child in a boat throws a 6.4 kg package out horizontally with a speed of 10 meters per second. See, there's a child here. She throws a mass of 6.4 kgs like this. The mass of the child is 26 kgs. So mass of the child is 26 kgs, and that of the boat is 45 kgs. 45 kgs. Okay. The velocity of the boat immediately after the throw. Now, usually, what students do is, since they have learned about Newton's third law, the first thing what they do is, okay, if you are throwing this one at 10 meters per second, I should also be kicked back. Okay, because action is this, reaction should be backwards. And hence they write this as A is the right answer. Okay, but A is not the right answer. The reason is because your Newton's third law of motion is applicable only on forces. Now, what is given here? Speed. Okay, if I had asked the same question, if it was asked something like, if I throw a packet with a force of 10 Newton outwards, now what is the force I get back? Then I can say that I am also getting a force backwards 10 Newton. Okay, because that becomes an internal force. Now, as a result of this, okay, first thing is we should read the problem correctly, what is being asked, and then we need to apply it. Okay, so towards it, now what do we do here? Now you see, you are throwing. So this is an internal force over here. So therefore, the momentum before you throw is nothing but mass of the object multiplied by velocity, which should be equal to 6.4 multiplied by 10, which is 64 kg meter per second. This is the momentum before you throw. Assuming the boat is stationary. Then what you do? So because you throw, the boat is now moving backwards. Okay. So as a result of this, now momentum after collision should now be equal to, after explosion should be equal to 26 plus 45 multiplied by V dash, which we do not know what is this. Okay, but we know that in case of an explosion, you would have learned about the conservation of momentum in explosion. Okay, you have a bomb, for example, you have an object now which explodes. Let us say this mass is m, this mass is m. So when it explodes due to internal force, this object will move like this. Okay, with a velocity. If this is given to you, and this object will move in this way, which is v1 over here, right? So we are going to equate these two. So which should be 64, and this v dash will now be equal to 64 divided by 5 plus 6 is 11, 1, 5 plus 2 is 7, 71. Okay, so if I calculate this, this comes out to be equal to 0.91 meter per second. Okay, now you see this 0.91, what is the direction of the 0.91? It is in the opposite direction. So this should be a negative. Okay, for the conservation to obey. So this should be a negative one. Thus, you can say B is the right answer. So A is an incorrect answer. Hope this clarifies the concept on conservation of momentum. In the next class, we will see much more on mechanics. Thank you. Thank you for watching. Like, share, and subscribe to my channel if you like this video. Thank you.